Our final assumption is that survival is selective. This is selective survival and reproduction. I also, in my notes, have included overproduction as part of this. And so when we look at what's going on here, what we're interested in is what happens as our individuals mature. So we're again going to look at our stickleback population here, and in this case what we're looking at is our initial population of hatchlings. So these are the new individuals. They're going to have to mature before they can reproduce. So we can click the hatchlings mature button here, and when we do that, we can see that our pattern stays roughly the same in our murky water conditions. And then if we have our fish reproduce, we can see that our mean plate count falls just a small amount. We can mature those hatchlings, and you notice the mean plate counts here are the same. We can have the fish reproduce. Mean plate count stays the same, fish reproduce, and you'll notice that as we do this, there is very little overall change in the mean plate count of our hatchlings, and when our hatchlings mature, the mean plate count stays the same. We're going to switch to clear conditions and see what happens on now. So again, we've got our hatchlings here. We're going to allow them to mature, and when they mature, you'll notice that now we have a difference. So if we look at our graph, we'll notice that there is a smaller number of individuals surviving that have few bony plates, while the ones that have more bony plates seem to do better in terms of survival. So we're seeing a change in the mean number of bony plates during survival. If we allow those individuals to reproduce, again, we see a drop in the number of smaller bony plates. If we allow those individuals to reproduce, we get a continued climb in the mean number of bony plates. So in this case, the change that is occurring is due to the survival of the hatchlings that have more bony plates and the loss of the hatchlings that have fewer bony plates. In each generation we run this, we see that change occurring. That's because we're set up a situation where there is a differential survival of the individuals that have more bony plates. We can reset this and turn off that differential survival. So now when we run it, what we will see is that the individuals should all have the same chance of surviving even though the water is clear. So if we do the hatchlings mature, you'll notice everybody drops about the same amount, so our mean value is the same. Fish reproduce, mean value is about the same. Run it again. Each time we're getting about the same amount of change. So we're not seeing a tremendous amount of growth as we did before. We're not seeing much difference between our populations before or after survival. And this is very much like what we saw when the water was murky. So when we remove that selective survival, we see much less change going on a generational basis. What does that mean in terms of our entire population? Well, we can again go and see what happens. So again, when we run it with it murky, and we have all of the elements in place, we see very little change. When we make it clear, we see an increase in the number of individuals with bony plates. If we reset it and get rid of our survival advantage, while we run it while the water is murky, we see almost no change, just like we did before. But once we clean up the water, where before we saw change, you'll notice as this runs, we see very little change. So now the advantage that was there before, because you had better survival of individuals with bony plates, is now lost, and without that we get no natural selection and we get no change in the population.